hope you'll catch up with me the last two lessons. Okay, and morning I had a live session, some of you joined, and now I'm going to discuss about last two lessons, right? So last two lessons cover Newton's first law. Let us see. So this lesson is last lesson, and I don't believe we will see something like that happening again. So it's about biomechanics. So biomechanics is comprises of Newton's law, and then types of levers and their applications in sports, and then equilibrium, dynamic and static, and center of gravity and its application, and then friction and sports, and projectile in sports. This is what is this lesson covers. So understand what is Newton's law of motion and its application. So let us go for this part. And what is this impossible kick? Roberto Carlos' goal in 1997 defied physics and still impresses scientific today. When the famous free kick happened, physicists from all around the world were baffled by the images. That goal was catalyst for many studies and analyses about aerodynamic and the ball's curve that day at the Stade de Zerland in Lyon. One of the most famous studies was conducted by four French scientists, Guillaume, okay, Dupex, Annie Le Goff, David Ferry, and Christophe Clanet, and published in the New Journal of Physics in September 2010. Okay, so this is about how biomechanics came into form. That is what they wrote with their experiments. They wrote the case of soccer, where is twice as small as L, is worth commenting on. The ball trajectory can deviate significantly from a circle provided the shot is long enough. Then the trajectory becomes surprising and somehow unpredictable for a goalkeeper. This is the way we interpret a famous goal by the Brazilian player Roberto Carlos against France in 1997. The free kick was shot from a distance of approximately 35 meters, that is comparable to the distance for which we expect this kind of unexpected trajectory, provided that the shot is powerful enough. And another characteristics of Roberto Carlos' abilities, the ball trajectory brutally bent towards the net at a velocity still large enough to surprise the goalkeeper. So like this nowadays, so many so many goals are happening, and it's almost wonderful to see the biomechanics happening right in front of us using all physics. So here we are going to study about Newton's law in this lesson. You all know what is your Newton's law, the three different laws: law of inertia, law of acceleration, and law of third law is reaction, right? So first, Newton's law. Sir Isaac Newton was one of the greatest live session. நான் வரேன், வந்து பார்க்குறேன். Tomorrow I'll come. So this is about Newton's law. Sir Isaac Newton was one of the greatest scientists and mathematician that ever lived, and Newton came up with three general rules about the movement of objects. which are now known as Newton's three laws of motion. Okay, so in this first law of motion is law of inertia, where according to the first law, a body will remain at the rest or continue to move constant velocity unless acted upon by an external resultant force. Inertia is the objectives to keep moving in a straight line at a constant speed, okay, including a change in direction. Inertia is the resistance of any object to any change, resistance of any object to any change in its motion, and including a change in direction. Objectives to keep moving in a straight line at a constant speed. Okay, so application in sports, this first law. If you slide a hockey puck on ice, eventually it will stop because of friction on the ice. It will also stop if it meets something like a player stick or goal post. Okay, so this is the application of the first law. Skater gliding on ice will continue gliding with the same speed and in the same direction unless an external force acts upon the skater. So this is Newton's first law. It's about first law is a body will remain at rest or continue to move at a constant velocity unless acted upon by an external force. Okay, inertia is the resistance of an object to any change in its motion, including a change in direction. Objectives to keep moving in a straight line at a constant speed. Okay, so this was first law, and then second law you're going to see. Here you can see some more examples, right? uh, Bowling, and then okay, ice hockey. So here one more example is that unbalanced force is the player's foot, head, friction, gravity, and the net during a soccer game. A soccer player uses the body's muscles to create a force to move the leg and kick the ball from rest to motion until another player of the net stops or changes the ball's motion. So this is the first law. Okay, the object stays in rest until unless motion is applied to it, and in the same way the motion um, so body will remain at rest or continue to move at a constant velocity unless acted upon by an external force. So body stays in the rest position or travels in a motion until unless one external force is being applied. So it constantly moves in one velocity unless acted upon by an external force, like the ball traveling in the air until unless traveling in the floor until unless external force is applied to either stop it or either make it go further. So the first law is a body will remain at rest or continue to move at a constant velocity unless acted upon by an external force. Okay, inertia is the resistance of an object to any change in its motion, including a change in direction. Objectives to keep moving in a straight line at a constant speed. Okay, so these are the different things, examples you can give. The football being kicked. Okay, when a ball is thrown and is in mid-air, the only force acting upon it is the force of gravity. If the force of gravity did not exist, the ball would keep traveling at a constant speed until it was affected by an object or another person touched it. If this ball were thrown upward, it would end up traveling into space. So because of the gravitation only, the ball comes back. Okay. This is Newton's second law. Second law of motion is law of momentum, law of acceleration. As per the law, the rate of change of movement is proportional to the resultant force. Rate of change of movement is proportional to the resultant force and takes place in the direction of the resultant force when a net force acts on an object. The acceleration of the object it produces is directly proportional to the magnitude of the net force, is in the same direction as the net force and inversely proportional to the mass of the object. The more mass the thing has, the more net force has to be used to move it. In general, if you use the same force to push a truck and push a car, the car will have more acceleration than the truck because the car has less mass. Okay, so compared to the mass, the applied force acts upon, right? So application in sports, as in shot put, a player who applies more force and tosses the shot put at the correct angle has a greater displacement of shot put, whereas a player who exerts less force has lesser displacement of shot put. So this is one of the example for this second law, law of acceleration. Okay, law of acceleration is what? The rate of change of momentum is proportional to the resultant force, takes place in the direction of the resultant force. When a net force acts on an object, the acceleration of the object it produces is directly proportional to the magnitude of the net force. Okay, so another example is in a discus throw. If we want to determine the force acting on a discus accelerated 20 meter per seconds. Okay, so here you can see F is equal to m into a, F is equal to 2 into 20 and F is equal to 40 Newton. So this is one of the when a ball is thrown, kicked or struck with an implement, it tends to travel in the direction of the line or line of action of the applied force. The greater amount of force applied, the greater the speed the ball has. If a player improves leg strength through training while maintaining the same body mass, they will have an increased ability to accelerate the body using the legs, resulting in better agility and speed. So this is directly proportional to the the movement directly proportional. See, you can see the athletes here, and soccer example is the soccer. In soccer, a team will require more force to kick the ball high and faster. This law of motion is fundamental in soccer, so you can calculate the force needed to give a pass or the ball to the net without missing. So more force, the more acceleration, right? Now Newton's law, third law is every action has equal and opposite reaction for every action, and this reaction acts with the same momentum and the opposite velocity for every action. It states that whenever one object exerts a force on a second object, the second object exerts an equal, okay, this is about every action has equal and opposite reaction, and so the application in sports, in swimming, a diver needs to push down on the springboard, and he or she dives off a diving board, the springboard pushes back the force on you for proper projecting into the air during the performance. Okay, so this is law of reaction, the third law. There is an equal and opposite reaction for every action, and this reaction takes with the same momentum and the opposite velocity for every action. It states that whenever one object exerts a force on a second object, the second object exerts an equal and opposite force on the first object. When you walk on a floor and floor pushes you along, no force can act alone. Okay, so this is about third Newton's law. When you jump off a small rowing boat into the water, you will push yourself forward towards the water, and same force used to go ahead with them with will make the bat move forward. Okay. During any type of motion, if we need to jump, our legs apply force to the ground, and the ground applies equal opposite reaction force, ground reaction force, that propels us into the air. Okay, so this is about every action has equal and opposite reaction. According to Newton's law, the greater the moment of an object, the longer distance will it travel, stronger will it resist the external forces, speedier will cover the given distance, more stable will it remain in its orbit. So the longer distance will it travel, shorter will it resist the external force. So you'll have to say the right answer for it. Okay, Newton's first law of motion is known as the law of reaction, or law of inertia, law of effect, or law of momentum. So first one is law of inertia. Okay, and the second law of motion is also known as law of acceleration. Second law, no? Law of effect, resultant, inertia. Law of inertia. Okay. Second law. What is second law? It's equal, proportional to. Okay. Third one is every action has equal and opposite reaction. And what is acceleration to an external force acting on a moving object? Answer this if you know. Newton's second law of motion is known as law of reaction, law of inertia, reluctant force, law of effect. Which one is the answer? Okay, you just find out and then write it, right? Now about levers. So what are the levers? Lever is a type of machine. It is human body's mechanism for movement. And although it may be viewed as a part of the skeletal system, the role of the muscle in supplying the necessary force for lever action also should be kept in mind. Okay, the bony lever will be less stationary until they are moved by the mountains. Then are motionless until the nervous system stimulates them. So all lever systems are made of 4 components: the load, the fulcrum, the effort, and the lever. Okay. So here you will have to say where is the load, where is the fulcrum, and other things. So this is what is load, fulcrum, effort, and lever. Okay. So I'll come back to you on this lesson. You can see this lesson and be ready. Okay. Thank you all of you.